Good afternoon, ladies and gentlemen. Welcome to today's webinar on driving security operations center efficiency with network and endpoint data with machine learning, artificial intelligence, proactive threat hunting, and a lot more. This session is brought to you by Spire Solutions in association with Elastic and Corelight. Once again, welcome to our webinar on driving SOC efficiency with network and endpoint data. What do you expect, or what can you expect within the next 60 minutes? I'll give you a quick introduction of the session, what we're trying to achieve here. We'll talk a bit about network-related challenges, and not just challenges, but possible solutions. We'll talk challenges on the endpoint level. Again, not just leave you with challenges to go figure yourselves, but give you some practical remedial solutions for that. A bit of advanced threat hunting, XDR, where we combine different forces, and then we'll have a bit of engagement with you where you can actually ask us questions and we'll be more than happy to answer you. We plan to keep this webinar as interactive, as engaging as possible. So from time to time, you will see a few polls appearing on your screen. We encourage all of you to please participate in those polls. I'm Naveen Bharadwaj, the Director of Strategic Partnerships and Marketing here at Spire Solutions. I'm your host and moderator for today's session. For those of you who are not familiar with Spire Solutions, we are Middle East and Africa region's leading cybersecurity value-added distributor. We've been in the business for the last 13 years, serving more than 1,000 government and enterprise customers, working through our channel partners, 500 plus of them, in various countries across the Middle East and Africa region: UAE, Saudi, Qatar, Bahrain, Egypt, Nigeria, Kenya, and the list keeps going long. Most of you know us as your preferred security partner, and for those of us who haven't engaged with us, welcome to our webinar. Welcome to the Spire Solutions family. So during today's webinar, right, what we want to talk about is that automation and via machine learning can actually help your SOC staff handle the endless crush of alerts, because tons and tons of alerts have been created at your SOC. It's getting very noisy. Automation and ML can help you, but unfortunately, without the right data sources and without having the right set of analytical capabilities, you are facing a huge risk of straining workloads with more noise, with more complexity, and therefore, unfortunately, forcing your analysts into the alert fatigue layer or alert fatigue phase. We want to help you overcome that. Corelight and Elastic Security, our partners, are both rooted in open source, and together, when you combine them, they go above and beyond to help you maximize your operational efficiency. Their integrated solution, it combines the high-fidelity alerts and data from Suricata, from Zeek, along with the ELK stack of Elastic to help you identify anomalies, streamline the root cause analysis, and of course, not just reduce false positives, but increase the overall efficiency of your SOC. So get ready for modernizing your SOC. Get ready for increasing the efficiency of your SOC. Before I engage our first speaker for the day, I have a quick poll. I have a question to ask you all. What is your biggest network visibility gap in your SOC today? The poll question is on your screen. Please go ahead and let us know, what is your biggest network visibility gap in your SOC today? Is it DNS traffic, encrypted traffic, file activity, endpoint traffic? Is it all of the above? Is it none of the above? Or is there something else? Just drop your thoughts in the chat section if you don't find the option here. This poll will remain active just for 30 more seconds, so we encourage everybody to please participate. And as soon as the poll closes, I request our partners at Q&A to display the results to you. What is your biggest network visibility gap? What is your biggest network visibility gap in your SOC today? Let's close the poll and see what kind of responses we've received. Around 20% are facing DNS issues, 60% are facing encrypted traffic issues, endpoint traffic issues, and some are saying all of the above. It's actually a very interesting mix. And with that, I want to quickly bring on board Basil Shaheen, our first speaker, who's the regional head for the Meta region at Corelight, to take on from here and talk to us a bit more on the network level. Basil, the stage is yours.
Thank you, Naveen, and good afternoon, everyone. And very interesting to see that encrypted traffic and DNS, which is typically some of the biggest challenges that we see with organizations, but also endpoint traffic and file traffic. So quite a good mix. So what I'll be doing today is really digging a little bit deeper into the network side today, along with my colleague Karthik. And really, you know, when you think about advancing SOC capabilities, it's all about getting the right data. And that's exactly what we do at Corelight. So we focus a lot on giving the right network security forensics from the network to the SOC operators, to the SOC analysts, to the incident responders, to the threat hunters. And you know, a lot of times when you look at this from a wide angle, usually it starts with some challenges, right? So in order to solve these challenges, if we can go to the next slide, we need to highlight what those challenges are. So what we're seeing from our customers and from the people that we talk to in different organizations is that A, there's too many alerts. B, there's no context behind those alerts. And then, you know, because the amount of alerts is super high, the amount of time it takes to resolve those incidents without the context is also super high. So it takes a very long time to do that. And, you know, we hear a lot of things about threat hunting. Threat hunting is very interesting because it's a proactive approach. It's the opposite of incident response. It's the ability to go on the offensive and essentially find certain areas within the network that might be having some bad actors, or maybe discovering things about how the network is set up that would cause bad actors to get in. So typically those are the three main pain points that we see. Now, in order to solve these pain points, if we can go to the next slide, we need to understand the fundamentals of the right data that needs to come into the SOC. So there's been a lot of research done on this, and we typically find that two key sources are very, very important and very crucial. Not to say that the other ones are not important, but those provide the most value, or the biggest low-hanging fruit. And that comes from the network side, and that comes from the endpoint side, or the EDR. Now, threat intelligence, you can see, is number 3, and that's because threat intelligence helps enrich and identify the data that we find in the network and the data that we find in the endpoint, and be able to tell if there's any known threats or known malwares or known Trojans or things like that that are traveling through the network. So if we can go to the next slide, we'll spend a little bit of time just talking about how we can mature our model. Now, what you see here are 4 different levels. Not everybody is at level 4, not everybody's at level 0. Different organizations are at different levels depending on where they are in their SOC maturity journey. Initially, what most people start with is collection. So being able to collect logs from firewalls, from proxies, from DNS servers, and feeding those into a SIEM solution or security data lake to be able to have a single pane of glass where they can start their investigations. What they then realize is, okay, these log sources are great, but we need to look at endpoint, because endpoint is truly, capturing all of the events that happen on the host. And that particular data can become very important, especially with the work from home and the distributed environments that we have today. So that becomes very fundamental. So they typically add a solution like EDR. We then move to more procedural flows or ways where we can create certain rules and policies and dashboards to be able to visualize this data, to be able to have an ease of use when it comes to seeing in real time what's happening in our network. And typically to do that, we need to look at north-south traffic, we need to look at east-west, we need to look at endpoint. So this is where most organizations start deploying packet brokers so that they can assimilate all the different traffic. But then what they run into is the quality of the data that they're capturing is very, very thin. And that's when they start thinking about getting more details from the network. And that's when technologies like Zeek, which are very famous in the open source world, that allow people to capture network metadata and essentially be able to analyze it in a very easy to use fashion. And that's when they typically install or add these capabilities to their SOC. And then finally, once they have all these wonderful data sources, they are able to then now create automation. They're able to leverage the artificial intelligence, machine learning, to be able to crunch through all of this data and be able to help and find ways to make the life of the analyst or the incident responder much, much easier by pinpointing the needle in the haystack, as they say. Next slide. So what we are bringing to the table as Corelight and Elastic are essentially the 4 key technologies that you would need to build a security operations center. Again, there are other technologies like SOAR, for example, and you know, other technologies that you can enable, but these are the core foundational technologies. So Corelight works very closely with the network side, identifying the threats from the network side. Elastic Agent with Endpoint Security is focused on the endpoint, as the name says, and then everything can be brought together in the Elastic XDR, which is basically acting as a single pane of glass, the consolidation, the machine learning engine, the search engine that allows you to essentially go through this wonderful data. And then we add threat intel to enrich this data to be able to pinpoint a lot of known threats from around the world. Next slide. So if we take a look at this from a physical perspective or from a stack perspective, really, it's all about you know, having a stack, having the network, which essentially connects everything within the enterprise. So if you just click on the slide there, what you will see is obviously there's a lot of protocols that are traveling through the network, but these protocols are related to essentially your servers, your desktops, your applications, your files, your endpoints, and everything is connected with a wire, okay? So being able to capture that off the wire, being able to feed that into a processing engine, which is able to decode all of that traffic, generate rich metadata so that we're able to search it, we're able to apply IOC matching, and we're able to apply detections on it is very important. So that's where the Corelight layer sits. And then obviously the Elastic layer is where everything is going to be visualized, everything's going to be searched, and this is essentially going to be the single pane of glass for the user. And included with that is obviously the endpoint agents and the endpoint solutions, which will look at the endpoint. So anything that's happening on the host, anything that's happening on the network will be consolidated and brought to this single pane of glass, which is called the Elastic XDR. Next slide. So let's talk a little bit about the technologies that Corelight provides on the network side. So a couple of things I want to highlight. So Zeek is an open source framework which is commercialized by Corelight. And essentially what it does is it captures all the traffic. You can think about it as having 90% the fidelity of a full packet capture at 1% the size in an easy to use, easy to search, stitched together format, consolidating all of the protocols, all of the logs, anything that is traveling through the wire. This is captured directly from an out-of-band appliance. It could be a tap or span port. What then happens is, along with this metadata, a lot of behavioral detection gets applied to be able to look for certain anomalies. Some of the most famous ones are C2 detections, lateral movement, data exfiltration. These are the most common ones that typically bypass the perimeter security and are a great example of why network security monitoring is very important within the SOC to be able to identify those threats. We also add enrichment from threat intel, and this is our Suricata engine. This is what allows all of the known threats around the world to be mapped to the organizational's data or metadata that is traveling through the wire. We also have functionalities to capture packet for anything that is not understood by the metadata, so that we have full forensic lifecycle or chain from metadata to file extraction to packet capture to threat intelligence matching. So this particular platform covers everything that you would need from a security lens looking inside the network. You can think about it as a very advanced CCTV sitting in the network, looking for bad actors, bad activities, and bad behaviors within the network. Next slide. So once we put all this together, and we just want to show you what this looks like from a technical perspective or from a diagram. So what you see here, all the wonderful Zeek logs that are created, these are all, again, like I mentioned, interlinked, they're stitched together, and they're common schema, they have common timestamps, and they have very important pieces of information. So what you see here is a connection log, which contains all the session information. You can see some famous logs like DNS. So one of the biggest challenges with DNS is getting visibility into both the request and the response. This is all captured with Corelight's DNS log. If you see here files activity, This captures all kinds of information about files traveling through the wire. This includes the cryptographic hashes, the MIME types, the file sizes, where they came from, where they went, because all of these are linked to each other. So a good example of this, you could also see an SMTP log, which is an email activity or metadata log, along with an HTTP log. A good example of this is something as simple as a user, getting an email, clicking on a link, going to a website, downloading a file. That whole chain of activity is captured, and all of the metadata is captured. So from the email log, we can see, who is the originator, who is the sender, what is the subject, and then we can connect that to the connection log to see how did this email come into the network. So which IP address did it originate from, which DNS did it access, and then we can see the link, which is a website, which relates to the HTTP log, which contains all of the information about the HTTP session, and then right down to the file, which contains all the information about the file activity that traversed the network. So being able to have all that information with a click of a button, without having to rely on traditional, security logs that are coming from firewalls or proxies that A, might be missing context because they're not as rich, or B, sometimes your administrators have those logging features turned off because of performance impact. Being able to rely on a dedicated security appliance, which is capturing all this information, is crucial to even thinking about doing any machine learning or any detection or any investigation or any forensics case. Next slide. So a lot of people showed interest in how do we get visibility into encrypted traffic? Well, one of the biggest challenges with encrypted traffic is most organizations have a hard time decrypting the traffic, not because it's not easy to do, but because it causes a lot of challenges. Some of those challenges includes compliance, regulation. Some of those challenges include data custody. Some of those challenges include simply performance impact on their existing systems, or perhaps causing difficulties or breaking the application when they do decryption. If decryption is not possible, Corelight provides a lot of insights into encrypted traffic without doing decryption. And the way we do that is we look at ways to identify malicious fingerprinted SSL sessions by fingerprinting technologies like JA3 or hash. We observe the certificate hygiene to identify broken certificates or self-signed certificates or any play when it comes to the certificates themselves, which is a very telltale sign or a good indicator of a compromise. And then we focus a lot on SSH, which is usually used by privileged users to access databases and very important systems within the organization. And we try to understand the behavior of that activity. We look at things like, brute force attempts or scan detections or reverse tunnels. And then we also look at very important protocols like RDP, remote desktop protocol, which are very common ways for bad actors to penetrate these types of systems. So all of these things can be accomplished without doing decryption. And these are what we call the encrypted traffic insights or inferences that Corelight provides. So wonderful ways, and we've had amazing reviews about these types of methodologies for being able to inspect encrypted traffic without doing decryption. Next slide. So the way this works is, in order to capture all this traffic, we need to position these sensors wherever it is important for us to have that visibility. So whether you have a distributed environment, whether you have a single data center, whether you have a cloud environment, we have the ability to place different kinds of sensors, whether they're physical, virtual, or cloud, and capture all that traffic and feed all of the metadata as well as the alerts to the XDR platform, in this case, Elastic. And then once we have all that data there, we are able then to start an investigation and combine that data with endpoint data to have a 360-degree view, including enriching that data with threat intel at the source and at the XDR level. Next slide. So how this works is we sell appliances, we license them based on throughput, and you have the ability to mix and match them and configure them in multiple locations so that you have all of them connected to a single fleet manager, which gives you complete manageability across your entire estate. That is pretty much it from my side. I will now pass it. Oh, a couple more things I just wanted to highlight. In terms of how you control the data flow, you have full control over which data types you can send to your XDR, to Elastic. You have the ability to fork and filter the traffic. You can put it in long-term storage. You can put it in hot storage so that it's easily searchable. And the best part about this is the solution comes with out-of-the-box dashboards, if you go to the next slide, which are giving you all of the visibility in real time that your SOC people want. Now, the beauty about the Elastic solution is it's so customizable. So whatever you get out of the box is just the start, but the ability to create your own custom dashboards on the fly in minutes or seconds for all of the important pieces of information that you want to see in your security operations center to give your L1 teams a high-level view. You can even go and create, L2 type of dashboards, which are more comprehensive, more detailed, and then you can definitely drill down into these dashboards and go to the raw metadata. Next slide, and that's pretty much it for me.
Brilliant. Thank you, Basil. Now, before we bring in our next speaker, we promised that we want to keep things engaging. You learned a lot about the network side. We're going to talk about the endpoint side as well as the XDR that we promised earlier. But before that, a quick poll. What does your organization currently rely on to detect, prevent, contain, or recover from a ransomware outbreak? You see, there are a bunch of options right in front of you. EDR or XDR with ransomware detection and prevention capabilities, backups, email security, patching, detection rules on your SIM or security analytics platform, maybe all of the above, maybe none of the above, or something else that's not listed out here. So please choose all those which apply to your organization as of now. And if we are missing some options, you can just type it up in the chat section. What does your organization currently rely on to detect, prevent, contain, or recover from a ransomware outbreak? Everybody please participate. Everybody please cast your votes, because that will help us get an understanding of where you currently are. And then the next speaker, James, will take it from there and try to elaborate on some of your pain points, try to elaborate on some of your challenges, as well as try to elaborate on what you're currently doing and what more you should be doing. We'll keep the poll up for the next 10 seconds just to allow everybody to participate, and we'll close the poll and display the results. All right, let's end the poll and display the results, please. Brilliant, brilliant. Majority of you have participated. A good, more than a fourth, almost a third of you have answered EDR, XDR. You've talked about email security. 75%, that's impressive. 75% are talking about backups. So let me quickly bring on James. James is the product marketing director at Elastic Security. He's going to walk us through the EDR side of today's session and a lot more. James, over to you.
Perfect. Thank you, Naveen. Thank you, Basil, for your section as well. Hi, everyone. Good afternoon. My name is James. I'm going to be walking you through all the latest and greatest from Elastic when it comes to our endpoint solution, or combining that, in a more overarching XDR style fashion. Going to be talking and weaving in all the goodness that Basil was talking about when it comes to utilizing endpoint and network data together, as well as running things like machine learning on top of that data to give your SOC even better efficiency when working with these threats, because it's not an easy task, right? There's a ton of challenges with data, and let's see what we can talk about to help overcome those challenges. So we recently branched into XDR as Elastic. For those of you who have been following our journey, we've done this back in August this year, so not too long ago. And what we've really done is brought in the world of traditional SIM and EDR, Endpoint Security. So we joined forces with a company called Endgame back in 2019. And we've been working since then to bring everything under one platform rather than having a separate EDR product and a separate SIM. We've seen time and time again that having those solutions separated isn't working out too well, or if it's working, it provides a lot of extra complexity and an extra time to ask certain questions. So for example, if you have a team that's sending all that Corelight data to your SIM, you have another team from the endpoint side working with endpoint alerts, you have to ask each other questions, right? That might take time. If you see someone logging in and you've seen malware happening on a host, hey, can we check our Corelight logs to see if that file was present there? Well, let me go back to that other system and check it. So these are the sort of questions where XDR is trying to help, bringing in all the solutions under one roof. Why have we called it limitless? So in reality, it's because of the visibility, prevention, detection, and response capabilities that we can provide. When we talk visibility, it's because of our now what we call Elastic Agent, which has hundreds of different integrations, which allows you to bring data in, as well as third-party solutions like Corelight and like others who have natively written outputs to the Elastic Stack. And again, like Corelight, they're using our Elastic Common Schema to normalize everything. So you as a user don't have to do anything to make sure that data works across the stack. When it comes to prevention and detection, we're really talking about first and foremost prevention on the endpoint side, when we're looking at things like file-based malware, ransomware preventions, we'll get into more details about this, memory threat detections, behavior rules running on the endpoint themselves, and being able to stop it at the endpoint as early as possible. If we happen to miss something, or if something slips through the cracks, being able to detect on the SIM level with things like correlation rules is also extremely important, running things like machine learning to help with that as well. And this is where extended comes in, just because there's the concept of defense in depth, right? You have something at every stage trying to either prevent, detect, helping your teams. And as well, you heard Basil talk about they have detection capabilities on the Corelight level as well. That is yet another layer at the network stage. And then bringing in response. So Basil mentioned SOAR platforms. We currently integrate with several different SOAR platforms. We don't offer SOAR natively just yet, but we do allow you to really easily integrate with systems like Swimlane, IBM Resilient, ServiceNow SecOps, and a few others as well. And we're firm believers that we should allow you to integrate with any platform you wish. So there's also the concept of being able to use just generic API calls as well. This is sort of it gives you a good overview of everything together. You also see cloud on there. We recently joined forces with two companies, CMD and Build Security, which is going to bring us into the cloud workload protection space. We're not there just yet, but it's good to put it on the screen because it covers sort of our overall visibility over the next coming months. This is highlighting now as well what it looks like, because some of you might be used to the ELK stack terminology, Elasticsearch, Logstash, and Kibana. We've kind of moved on a bit from that now because of Elastic Agent. You can call it whatever you like. If you like ELK stack, you can keep calling it ELK stack. We now say Elasticsearch platform just because it's grown into so much more than just Logstash. So these days, we talk about our integrations, which are being collected via which is providing a way of collecting data via agent, and then you can use them across our three solutions, obviously security, observability is another, and enterprise search. And of course, you can run Elastic Stack however way you wish, whether you want to run it in our cloud platforms, in a hybrid approach, run it on-prem, Docker, Kubernetes, you name it, there's no limitation there. Bringing everything together, what XDR really allows you to do is, instead of having all these different looking at all these different platforms for all your different solutions, you can bring them all under one roof, right? That is really what we're trying to help with here. And you'll notice there are other EDR solutions on the screen, which is totally fine for us, by the way. So even though we have our own endpoint security solution, we know users have existing technologies. We don't expect you to just grab them and chuck them out the window. That's not the way we work. You can still bring in those data sets and use them in a similar fashion. Right, so thanks to, again, our integrations in the Elastic Common Schema, we will work with any data you give us. Like we're totally data agnostic in this case. This is just more of a visual overview of the prevention, detection, and response capabilities. I won't spend too long on this slide just because we're going to get into details within the demo. And again, bit of a better overview, focusing just on the endpoint security side. You'll see here things like response actions as well, which is the R from the traditional EDR, which is things like host isolation, and there's more coming up as well. Going over some things like our detection capabilities, so anything from your traditional detection rules using correlation, which we'll be talking about how we can use this language, which is EQL, our event query language, to combine endpoint network data like Corelight to have really efficient detections. Going deeper and looking at endpoint level preventions and detections, like we have here for things like shellcode detection and memory. We can see screenshots of typical ransomware there as well as Linux-based detections as well. And then machine learning, of course. So we'll be talking a bit about machine learning as well. So here we have an example of some of the machine learning jobs that we provide out of the box, as well as like an example of what the results look like. These cover a wide variety of technologies as well. Network is one of them. And one more, because we actually have 2 levels of machine learning as well. So the previous screenshot, this is talking about our traditional unsupervised models. But more recently, we've started to provide supervised models for network data as well. Things like being able to detect domain generation algorithms, or commonly known as DGA, as well as URL spoofing. So if you're bringing in the DNS logs from Corelight, if you're bringing in HTTP events or via Corelight or whatever else, we're able to use those with our unsupervised models. And this is all thanks to having that ECS, the Elastic Common Schema, because then it would just work based on what we've provided. There's an example. I just wanted to highlight again that defense in depth strategy, a recent malware that we've seen, DarkSide, ransomware I should say, at every stage highlighted here, we would have been able to detect or prevent in some way or fashion. So it's just good to get a holistic overview of what we're able to do. You'll see though, one of the reasons why I brought this up in particular, because one of the things DarkSide did was move laterally with things like RDP and beaconing activity. And as Basil mentioned, being able to dive into RDP protocols and detect C2 beaconing is extremely critical to be able to detect this sort of behavior as well. All right, before I jump into my demo, I'm going to hand over to Karthik from Corelight to demonstrate some threat hunting capabilities with the Corelight data in Elastic. Karthik?
Thank you, James. Let me quickly share my screen.
And while Karthik is trying to load his screen, we encourage everybody to drop in your questions in the chat section or the Q&A section. We'll try to answer a couple of your questions towards the end of the session. So please go ahead and start dropping in whatever questions you might have. Over to you, Karthik.
Thank you, Naveen. So building upon what Basil and James have been talking about so far, what I'm going to do is take you through a quick demo so you get a better understanding of the capabilities of Corelight and how you can visualize the data that we create and send over to Elastic as well. So a quick overview of the Corelight sensor itself. It's very straightforward to configure the logs to be sent to Elastic. We have an API integration and we are Elastic Common Schema compliant as well. So, you just define the server name, the prefix, and off you go. Now, at the heart of Corelight lies the behavioral analysis packages that Basil spoke about earlier during his presentation. So there are a number of different packages that we use to give you those alerts and detections. The packages. So let's say, I want to look at post bodies. So when there is an HTTP session, I want to have a look at what is being transmitted in that post session. I want to look at the internal malware family if there's any activity related to that. Or I want to look at, let's say, J3 hashes, which is particularly useful in detecting malicious SSL communication. And I'll show you an example as well in terms of how useful it is. Or for that matter, I want to look at MITRE TTPs. So I'm going to show you examples of all of this during the demo as well. So it's just very simple, straightforward to just turn on these packages. And you also have additional configuration options if you want to further fine tune any of these packages. So, you can change some thresholds, define, let's say, a whitelist, so ignore if the activity is coming from a certain IP and so on and so forth as well. Now, we talked about the encrypted traffic and the C2 collection as well. So the encrypted traffic essentially, gives you the ability to look into certificate hygiene, let's say, certificate validation errors, like, self-signed, or whether it is newly created or if it has failed some kind of validation. including detecting encrypted DNS and looking at non-standard custom crypto kind of activity, along with the ability to give you RDP and SSH inferences. So, for example, let's say you want to find out if this was a brute force attempt, or was that brute force attempt successful? Was it an automated password authentication, or was it an interactive password authentication? Were keystrokes being used when the client was logged into the server using RDP or SSH? And we give you all these detections, which are very, very useful as indicators to start off with the analysis. Similarly, with the C2 package, I've turned this all on so we can get better detections. And then, we allow you to customize packages and scripts, and there are analyzers. You can import threat intel that you're working with, and so on and so forth. Now, in terms of how the data looks in Elastic itself, we have a lot of pre-canned dashboards that you can use in order for you to get started with it. And I'm going to take you through a few of the key dashboards that are commonly used in any incident response or threat hunt kind of a scenario. First up, we talk about our connections log, or the con log as we call it, which not just gives you the net flow type information, so the 4-tuple information that we commonly call the source, destination, IPs, and ports, plus the protocol. It also tells you a number of other parameters in terms of the top talkers, the total inbound, outbound data flows, the services, and so on and so forth. So if there is some service that you're not expecting to see there, or there is some source destination IP which is very, very chatty, those are sort of things that you can look or dig deeper into. Similarly, DNS is an extremely important protocol when it comes to network detection and response and network security monitoring. A number of different organizations we work with do not have a full visibility of DNS, and we at Corelight have the ability to capture not just the queries, but also the responses, and then we give you full visibility of all of that. HTTP as well, there is the reverse proxy and the forward proxy kind of traffic that we look into. Some of the key widgets that you can look into is in terms of distinct user agents or rare user agents, rare destination domains, and so on and so forth. I'm just going to go back to the DNS dashboard to sort of just focus on one of the couple of key things that you will also see during a threat hunt scenario I would use. So a couple of key widgets that we often look into is errors in DNS lookup, or queries to non-existent domains, right? So it begs the question, if the domain doesn't exist, why is the system querying it? And here's where you will typically find things like pseudo-random domain names generated by domain generation algorithms that James was talking about earlier. And we have the ability to look into that kind of traffic as well and pick up and alert you based on that. Moving on to one of the other key areas that we are quite sought after for is the files log that we have, which gives you the cryptographic hashes, among other information, which allows you to fingerprint file hashes and then look for those hashes in your environment to, let's say, look at lateral movement sort of activity, or you could have a threat intel feed with file hashes populated, which could then alert you again if there is something known malicious being seen in comparison to the list of threat intel that has been imported. I was talking about the encrypted traffic earlier, and here's a dashboard that sort of lets you get started with that and also lets you dig deeper into it. So some of these 2- and 3-letter acronyms are explained here. So like I mentioned earlier, so there is brute force guessing if it is a success or not. Then there is keystrokes being used. There is automated password authentication, and so on and so forth. Now, in terms of the alerts and the detections that Corelight provides, we talked about the IDS engine that is built into the Corelight sensor, which is the Suricata IDS engine. So all the alerts would bubble up from the Suricata engine, and you would be able to visualize them in the Suricata dashboard that is also pre-created within Elastic. And obviously, you have the ability to dig further into this and get more context about why this happened. And this is really important when you have a disparate system. And this is one of the popular use cases as well for us, because when you have a separate IDS system which is just alerting and you don't have the associated metadata to look into it, which is where a lot of the security operation centers are suffering from this alert fatigue. They are unable to distinguish between an alert and the alert. So, and that's the ability we provide in terms of tying these two technologies together, giving you that information where you can dig deeper into any of the alerts. I mentioned that we have the ability to ingest threat intel. That intel could be in the form of domain intel, IP intel, file hashes, JA3 hashes, and so on and so forth. You will be alerted based on any matches, and then you have the ability to come here and dig deeper. And last but definitely not the least, in fact, one of the most important aspects of Corelight, and I mentioned earlier, is the behavioral analysis packages. So all the alerts coming from the behavioral analysis packages will get bubbled up into the notice log. So you notice there are some alerts here. These are coming from the MITRE Bazaar package that I had enabled when I was talking about the sensor. So it's telling me there has been an attack pertaining to lateral movement. You can, take a look at the associated alert and its metadata. And, this is usually a starting point to sort of dig deeper into it. So let me do this. Let me just quickly take you through a scenario wherein I'm digging deeper further into this lateral movement alert that I'm seeing. And here's the actual log itself in its bare bones. So you can see that it gives me a lot of metadata information. So the timestamp, the source destination addresses, the ports, protocols, and what is the exact activity. So the notice message says that it's an SMB file write to admin file share. And because of that, it has been determined as a lateral movement attack. Now, it also gives me the exact destination IP, the path that was accessed, and it seems there was a executable file that was also pushed through during this activity. Now, if I wanted to dig deeper into this, my starting point would be the UID that Basil talked about when he was talking about the Zeek logs. The UID basically stitches together all the different logs, and I'll show you just now how it does that. So I'm going to pick the UID, which I seem to have lost. There it is. So I'm going to take the UID and I'm going to do a search for it. And I don't even have to write this whole expression. That's the beauty of Elastic. It gives you that free-form searching. So I can just paste that that value which I just copied, and I would get the results. Now, in terms of the UID stitching together the various logs. So if I go to event.dataset and if I list out the event.dataset, you will see that this single UID, which has had 150 hits, is basically telling me that there are other files or other logs that are stitched together in here. We've already seen the notice logs, so I'm going to get rid of the notice logs. I can filter them out. So it will give me more information. So there is connection logs, there's Suricata log also associated. There is obviously SMB activity as we saw in the notice, and there is RPC and so on and so forth. Now, in terms of the log itself, as I said, you can get into looking at various metadata elements, or there is another way of going about doing this is I can go to my dashboard with the connections log, and I can filter it down to that particular source IP address to find out what other activity or what other services or protocols was this host communicating on. And I quickly notice all these different services out here. So there is SSL, DNS, HTTP, and so on. And again, I have the ability to, let's say, zero in on any of these to get more information. Now, when I get into SSL, I also notice that the responder ports is not just 443, but it is also on non-standard ports like 447, 449. And remember, I had turned on the ability to create JA3 hashes when I was talking about the sensor. And this is where it's really, really useful in the context of SSL traffic. And I've created this table for us to be able to visualize this easily. So here's the host in question, and it's communicating with all these public IP addresses on not just 443, but on non-standard 447, 449 ports. And what's worse is it's failing the SSL certificate validation as well. So it's using a self-signed certificate. I mean, I can understand if you're communicating within your dev environment on self-signed certificate, but obviously communicating with an external third party is a malicious or a dangerous thing to do. What's even more surprising is that even though the IP address is changing, the port number is changing, the JA3 and the JA3S hash pair remains exactly the same. And this is usually indicative of malicious activity. And we can confirm that by taking this JA3 hash and searching for it. JA3, by the way, is a standard created by Salesforce. So I'm obviously searching this with Salesforce. So notice this is the exact match of the JA3 hash and the JA3S pair that we've picked up. It pertains to a known prig port and its associated C2 server response. So what we have here is actually command control activity coming from this internal IP, which is trying to communicate with all these different IP addresses, which is hosting the command control, let's say, server basically. And which is why, even though the IP is changing, the port numbers are changing, the JA3 and JA3S hash pairs are exactly the same because the client hello packet and the server hello packet are exactly the same.
I think,
because
sorry to barge in the interest of time, we need to expedite the demo and also quickly switch to James' demo, perhaps in the next minute or so.
Yeah, I will do that. Thank you, Naveen. So yeah, so in the interest of time, I'll just quickly wrap up. So what I do next is I take a look at what this system was doing in terms of DNS queries. Again, I pointed out, the errors based on pseudo-random domain names. I take a look at some of the HTTP activity that the system has been doing, and some of the DNS queries were translated into HTTP requests as well. And when I take a look at the actual logs, I also find that there are some executable files that are being downloaded, and those files were actually masquerading as an image file. But because we have the ability to look at the true file type, we detected that it's an executable file. Since I see executable files, I'm going to next have a look at all the different executable files from this particular host coming in from all these different sources. I've picked one of the MD5 hashes and ran a quick virus total check, which tells me that it's malicious. And last but not the least, to sort of circle back to the original notice log that we were investigating, which was about lateral movement. When I search based on that MD5 hash, I can see that this host 101 is what originally downloaded the file from this external host, and then it has transmitted that file to 30.5, which also actually happens to be the domain controller server of that organization. And then this host has also reached out to the same external host and further downloaded malware. So what we've done is sort of gotten to the root cause of a particular alert, and without even touching the endpoint. And I'd just like to wrap up by saying that imagine with the power of the Elastic XDR and the Corelight network detection and response, you can go much further in terms of being able to do your analysis and investigations and reduce your incident response time. Thank you. Back to you, James and Naveen.
Brilliant.
Perfect.
Thank you.
Thanks, Karthik. I'll keep mine short, so don't worry too much. We should still be on time, Naveen.
Perfect. And I also already have a couple of questions that came into me privately. So as soon as you're done with the demo, it seems like there's one or two questions for you and one for Basil, which I will ask.
Sure. So similar to Karthik, I'm just going to start off with how we bring in endpoint data these days, because without the data, of course, you can't use any of that XDR goodness. So we're looking at our Elastic Agent fleet configuration page. So I have 4 agents in this case, and they're assigned to policies. And if I just looked at one of these hosts, we can see sort of what data we're collecting. So we're running our endpoint security integration. We're collecting some additional like Windows event logs like PowerShell. We're actually running OS Query Manager, which allows us to query in an OS query fashion, collecting system logs. And we also have some other network packet capture data as well in there. So unfortunately, I don't have Corelight data streaming into this cluster just yet. Thankfully, Karthik's data was really good. So I'm just going to simulate it with some generic packet capture, but it would be pretty much exactly what you'd be able to do with Corelight's data within Elastic. So a really quick overview of how we bring data in these days. Even within the endpoint security integration itself, just to show you there, turning on certain protections is as easy as clicking a button or ticking a checkbox. So if you want memory threat protections, if you turn it on. If you want ransomware, you just turn it on. If you want to start collecting DNS and file events from your endpoint, you just turn them on. And that's it. That's all it looks like these days. So now that we have all this data streaming in, what can we do with it? So obviously, the first thing to talk about would be alerts. So I have some alerts here, which were generated after I ran a specific malware. In this case, it was APT28, if anyone is familiar there. And I just want to highlight some of the alerts that were picked up on the endpoint side first. These are all provided out of the box, by the way, both endpoint and the SIM based rules. So if we start off with something like a host file modified, we can see, thanks to our event rendered view, really easily what happened there. So it's saying, hey, this user on this host overwrote this file in this directory. Just to point out though, so far we don't know why this happened yet. It's just the first alert we're looking at. But if this happened to be coming over from like a network copy, this is something Corelight would have been able to help with and pick up. So because we're hashing the files, we would have been able to use the hash that Corelight is generating as well, correlate them and say, oh, this file was not only written on disk, but it was also transferred from this network source. So just want to give you an idea of how these two can start coming together. I have created some of these for you just so you see what I mean, but just to give you an idea of how the two technologies work together when they're in a singular platform. Then we start off with malware detection alerts. So we have full malware detection and prevention capabilities across all 3 operating systems. And this includes not just execution of files, but as soon as files are written to disk. It's using a supervised model built based off of 250 million malware samples, so it's not hash based. But you can see this is telling me, hey, listen, administrator in this host was detected creating this particular malicious file in this directory with these arguments. And we can also see, because we're using our endpoint security integration, we have more of a process tree view as well. So if you prefer looking at things this way rather than textually, we provide this sort of view for you as well. We have other rules like malicious behavior detections on the endpoint. So before things reach the SIM, we're analyzing things on the endpoint to look for specific bad behavior. So just to give you an idea of things happening on the endpoint side as well. In this case, if any of you are familiar with this malware, one of the things it does, if we look at one of the later rules here, is it actually starts making network connections out over run DLL32, which is a bit suspicious, right? Because you should never really have, especially when the commands are ran via ordinal. So what I wanted to, actually I have the alert here. Yeah, so you can see here in this case, after the malware was detected and it ran, we had run DL32 make 21 network connections. So this is the visibility that we have on the endpoint. We can actually see that the network connection in this case was a DNS request to cdnverify.net. But because at this point I'm only focused on endpoint data, I might not be 100% confirmed that this malware successfully exfiltrate the data? Did it hit my perimeter? Did it go through any of my other network devices? So far, I've only seen it happen on the endpoint. So why don't we use that capability to correlate these events to see if we had data traversing our network devices or diving deep into certain protocols. So for example, Karthik was mentioning the capability to look at TLS traffic. So one thing we can do here is we can do that. So I'm running here an EQL sequence query. And by the way, we're also going to start shipping these cross data source correlation queries out of the box. But just to see what you can build when you have these data sets working together. So if we wanted to check within like a 1 minute time span, if we had network events where we had TLS traffic, we had endpoint network events like we've seen before, so out of run DLL 32, and then even something like another network data set, like a VPC flow log, for example. And you can see we have results. So if you think of like, again, C2 communication, you have the DNS request, and then if it's leading to a TLS connection, you have the TLS handshake. In this case, I started off with there. Then we see the endpoint actually making the, or finalizing the connection. And then we see the flow event closing the connection as well. Thanks to, by the way, Zeek and Corelight's community ID here, we're able to correlate that this was the same traffic in the same way. This is really, really powerful stuff, having that community ID. So this TLS connection is definitely related to the network flow event that we've seen. So allowing you to build these sort of alerts really reduces your footprint on the SOC alerts themselves, because instead of having 3 individual alerts, you can now have 1. You can take it a step further, right? Because you can even do something like this, where you can build alerts on alerts. So like you can say malware detecting, making outbound requests on perimeter firewalls. So you can actually combine several different alerts together rather than just several event types together. So just wanted to talk about that concept within Elastic. I know we're really tight on time, so I definitely want to talk a bit about machine learning. So how would have machine learning helped in this case as an example? So if I open up our host view here, so I just want to click on a host that I have over here. One of the things we're doing in the background as well is we're analyzing all this data in an unsupervised and supervised fashion. So we're looking at what's normal and what's not in our environments. And we can see here we had a machine learning anomaly for anomalous network activity, where we noticed traffic to this IP address coming from this process. So we're actually tying in multiple machine learning jobs together here, saying, hey, we've noticed traffic on this IP address that is being come from around DLL 32, which is very unusual. We have an anomaly score of 62. And lastly, I'll just show sort of what we're doing with DGA from the Elastic side. So we've actually provided this supervised model that's continuously running on incoming data. So whether that's DNS traffic from Corelight, you can actually enrich that data further with our what we call an inference model to try and detect domain generation algorithms. So because Corelight is doing it themselves as well, it sort of highlights that defense in depth. So having multiple systems trying to detect DGA also reduces the false positive rate, because if you have 2 systems saying this is definitely DGA, that's what your SOC should be looking at rather than sifting through the false positives. I know we're tight on time, so that's where I'll end it with my demo. I did have one more slide that I wanted to talk about, which is the sort of the business value of using Corelight and Elastic together. In reality, it boils down to reducing the risk of your security operations within your organization, providing more efficient security operations, and lowering costs. We all want to lower costs. You know, security typically has the tendency to just spend, but combining those technologies together really does reduce those costs, particularly because, as Basil mentioned, you're collecting really rich network level data at like a much lower footprint than raw PCAP. And then if you use something like Elastic with our searchable snapshots feature, you can store that on blob storage and still search it. So all the dashboards that Karthik was showing, you can actually have all of those being run out of an archive, something like an Amazon S3 bucket. Naveen, I'm going to hand it back over to you.
Thank you.
Thank you, everyone.
Thank you, James.
Go
as they say, when people start talking about technology or platform, their passion and their love for the tool can just have them talking for ages and not bore the audience. So I'm glad that both Karthik and you were able to show the platform's power. I will take the liberty of requesting and taking 5 extra minutes from all our participants today, so you can answer a question and Basil can answer a question before we close the session. But my humble request for you and Basil is to answer in perhaps a minute or two. Because you're already here, James, one of the questions that I actually received from Abdullah on private chat is on what operating system does Elastic Endpoint Security integration detect and prevent against file-based malware?
Sure. So we run on all 3 major operating systems. So Linux, Mac OS, and Windows, both server-based and endpoint-based. So like Windows 10, Server 2019, Ubuntu, CentOS, and Mac OS as well, the more recent versions. So I should give you pretty good coverage.
Perfect. Great. Thank you. Basil, here's one for you. Dina is asking for the difference between Corelight Zeek and the open source versions.
Yeah, no, that's a great question. So obviously with any open source product, one of the biggest challenges is getting proper support. With Corelight, you have 24/7 support from the creators of Zeek and Bro. Not only that, we build the appliances, they're spec'd, they're secured, their performance, they can run at 100 gigs. We ensure minimal packet drop rate. We also provide you with a lot of detections that are not available in the open source, but we also keep the open source nature of the product. So if you do want to program and build your own detections and scripts, you have the ability to do that. So it's all about getting you a very easy plug and play device. No hassles. You know it's going to run. It's not going to drop packets. It's going to be highly scalable. It's going to be highly integratable. Everything's GUI. There's no command line like in the open source world. And you get to work with wonderful people like us. So that's my answer to your question.
Brilliant. There was another question, but I think you answered that as well as Karthik, which is around Corelight's supporting Elastic Common Schema. But I guess that was talked about once or twice while you were doing the presentation and while Karthik was showing.
Yes. Yeah, so Elastic Common Schema is very important because it normalizes all the data. So one of the big things about Corelight versus the open source is the fact that it's very standardized. So we provide the data in a standard format, and not only that, we also provide a lot of out-of-the-box dashboards that you saw in the demo that are available to customers to use, so that they don't have to spend time from day one to get time to value. So there's quick time to value, not only in the way that we provide the data in terms of the schema, but also in the way that we visualize the data. So it's all fully supported.
Super. And one last one for James. Does Elastic operate in air-gapped environments, particularly Elastic Security? This is one of the questions that came up as well.
Yeah, 100% we do. So obviously we understand that that's a very important thing to have. We know sometimes users do not adopt an EDR platform, especially within their server infrastructure, because they're cloud only. So we fully support air-gapped environments. So you can essentially do everything I showed without a single connection out to the internet.
Fantastic. James, thank you so much. Basil, Karthik, thank you for your time.
Naveen,
well.
there's one more.
Yes.
One more question.
Go ahead.
Somebody's asking, do you provide SOC support for OT environments? So one of the things we didn't talk about is the ability for Corelight to parse OT traffic. So things like Modbus, BACnet, Radius, all these types of OT protocols. Those are fully supported by Corelight, and those are available as part of the packages that we provide with the enterprise version of Corelight.
Very good. Useful information. So we encourage all of you to please read up a little more or a lot more on Corelight as well as Elastic. Get some information from the Spire Solutions team. Go to our website or go to Corelight and Elastic website. In the last 60 minutes, thanks to Basil, thanks to James, and thanks to Karthik, we hope, and I personally trust, that you have learned how to identify anomalies in your network traffic using machine learning and detection rules. You've learned about finding threats in encrypted traffic without necessarily having to decrypt. You've understood how to perform faster investigations, given the fact that Corelight and Elastic Endpoint Security work together beautifully, and you come up with that XDR and a comprehensive approach. With all of that in place, we believe you can now drive SOC efficiency much faster, much better, with network and endpoint data talking to each other and machine learning coming to play. Thank you so much, ladies and gentlemen, for joining us today in our webinar organized by Spire Solutions, Elastic, and Corelight. We will make some additional information available to all of you that have participated in this session, all of you that have registered for this session, and we encourage you to request presentations or demos or detailed conversations with our team. Thank you once again for joining, and see you soon. Have a great time ahead.
Thank you, everyone.
Thank you, James. Thank you, Basil. Thank you, Karthik.
Thank you, everyone. Thanks, Naveen.
Cheers.